Okay. So there are two types of these problems.
Yes.
There is what we call a full integer problem, where both x1 and x2, and what we're going to do here, all we're going to do is graphical. We're not going to do any simplex crap. Okay, just going to do graphical. But, so there's two types. There's one that's called an all integer problem, where both x1 and x2 have to be integer. So that's if you're producing cars. You're making two models of cars. Neither one can be a decimal, right? You have to produce 3.4 F-150s and 3.4, you can't produce 3.14 F-150s or 3.4 Ford Escapes. Can't do that, right? They gotta be whole numbers. The other type of problem is what we call a mixed integer problem, where one of the variables has to be integer, the other one does not have to be. Okay, and the problem will specify. It'll say, and x1 in it has to be integer. Where that comes into place, let's say you're making cars, but you're also making gasoline. Well, you could produce one car, but you can also produce 3.78 gallons of gasoline. Absolutely, right? So those are mixed integer problems. Okay? All right, so the way we start these problems off is we solve what we call the LP relaxation problem. The LP, linear programming, relaxation problem. Okay? And that is simply solving the problem as we did in chapter 2, or wherever we did integer, wherever we did linear programming. All right? Okay, so I'm going to put a problem up on the board here. We're going to solve this. All right? So the first thing we do is we solve this thing called the LP relaxation, which means solve the problem like you just did the extra credit. That's the same thing, right? Now that worked out to be an integer answer, 3 and 5, right? But it doesn't have to be, okay? So